You have probably heard of the term external cheat before, but you might have wondered what does it really mean and how do people create them. In this video you will find answers to all of that, so let's get started. Game hacking has a lot to do with manipulating the game process's memory. That is because the game values and variables you see and interact with while playing are actually stored in RAM, and you can access them if you have the right tools. One tool to access RAM is called Cheat Engine, but it is also possible to create your own tools for memory manipulation. They are usually called either external or internal cheats. When you start an external cheat, it starts up as a separate process which opens the game process and modifies the values this way. The second flavor of cheat software is known as internal, but we'll not look into it today. Let me know if you'd wanna see a video on it. Now, this video is a direct continuation of our game hacking video. If you don't have experience with Cheat Engine, I would highly recommend watching the previous video and coming back. Alright, let's go. By the way, this is the game we are using for practice. We used it last time too. You can use your programming language of choice here, but I will use C#. But don't close Cheat Engine just yet, these pointers are gonna be very useful for us. So let's open Visual Studio. If you don't have it installed, I will leave a link to a video where I show how to install it right here, but let's hit Create New Project. Let's select C#, let's do Console App, hit Next, let's name it Platformer Game External Cheat, hit Next and Create. Now, as it is maybe obvious already, writing game cheats has a lot to do with tinkering and playing around with the game process's memory. And for that, we need to define a way to open the process in our C# program, just like we were opening it from right here. And after opening it, we need to be able to read memory and write memory. And for all that, let's create a new class. I'll call it Memory. We'll be using it to play around with memory, and the cheat logic itself we will implement in program CS. Now here we will be utilizing the Windows API, which in C# happens through pinvoke. If you open a browser and search pinvoke.net, here we can find the signatures of the external functions that we need to call. For example, one is open process. If we search it up here, we want to use the kernel 32 version, and here we have open process, and there is the signature that we need to use. So let's copy this, go over here, paste it right here, let's hit Alt and Enter, do the necessary import, and here they have actually provided an enum for us with a lot of values, but I already have ready 3 of them which we'll need in our case, so that we don't have to define all of them. We want to be able to read a process, write a process, and this operation. So instead of process access flags, let's just do unsigned integer type, the way it is here. And let's see, here we also have an example of how we call it. It returns an int pointer, which is going to be the handle for this address. In our case, this is going to be the base address of the game process. If we go to Cheat Engine and we double click on one of these pointers, you can see that, as we saw earlier, we have platformergame.exe plus and some offset. And this part here, the address, is going to be what this method will return, this int pointer. Okay, so instead of defining a method like this, why not define a constructor instead? And let's also have a field for our process handle, which we will use later to write and read to the process memory. So let's do private int pointer, and let's just call it hproc for process handle. And here in the constructor parameters, let's pass an integer which is gonna be the process ID. And now let's take this call definition here, paste it, and let's do hproc is equal to this, and here we need to do process ID straight up, and here for flags, let's use all of our flags. Okay, now that we have our process handle, we need definitions for read process memory and write process memory from the kernel 32 API. You can look them up through pinvoke, but I have them prepared already, and here they are. For read process memory, we need the process handle, the address we want to read, the buffer where we want our output to be saved or the value to be saved, the size we are reading, and finally number of bytes read. For write process memory, a similar thing, handle of the process, base address where we want to write, the buffer we want to write, the size of the buffer, and it will return us the number of bytes written. Okay, So let's define wrappers for all of these methods so that it's easier for us later when we want to call these methods. This will make sense once we start calling them, so bear with me. Let's define one for reading a 64-bit integer. Let's do public, and we will do long. Long is the C# type for a 64-bit integer, so we will return a long, and let's call it read int64. And we will take in as a parameter the address that we want to read at. So let's do int pointer address. Now let's define a buffer where we will save our output. The size is gonna be 8 bytes for our 64 bits. And let's do the API call here. Let's do read process memory. And first we need the process handle we have already from the constructor. We need the address we want to read at, we already have that, passed as a parameter. The buffer we want to write the read data into, which we have already named buffer. The size we are gonna be reading, which we know is gonna be 8 bytes for a 64-bit integer. And finally, number of bytes read, we don't really need this, we can just discard it. Okay, and let's return. We want to return the buffer. However, we are returning a long here and we have a byte array, so let's use bit converter .toInt64. And here we have a byte array and a start index, so we are going to have the buffer and start index is going to be 0. Let's do another wrapper for a 32-bit integer. I changed it to int, which is the 32-bit integer, type in C#, change the name of the method, the size of our buffer, and the size here as well, and we are converting to int32 here. Okay, now let's define a wrapper for writing a 32-bit integer. Now we will do only for 32 bits, because if you remember, the int types here are 4-byte integers or 32-bit integers. For our demo purposes here, we don't need anything else. So let's do public int. I will explain why int in a moment. Write int32, and let's have as parameters the address as well as the value we want to write. Now the reason this returns an int as well is because we are going to just return the number of bytes written. So let's first define a buffer, and of course this time we want it to be the value. This is going to be the buffer we are going to write, but of course we need to convert it to a byte array. So let's do bit converter .get bytes, and we get the bytes of the value. Let's define an integer for bytes written, set it to an initial value of 0, and let's do the API call. Write process memory. And first we need to pass the process handle, so let's do hproc, the address which we want to write at, so let's do addr, the buffer, let's do buffer. The size is gonna be 4 bytes, and let's send a reference to the bytes written integer so that it populates it with the number of bytes written. Once we have done that, let's just return bytes written. Okay, great. Now we need to define one last method here, and let me explain. This will probably become a bit more clear once we actually start writing our logic, but if you open this address here, you can see we actually have a few pointer offsets here. And that is because this is not a single pointer pointing to our value. It is actually a pointer which points to another pointer, which points to another, and another, and finally, this final pointer actually points to our value. As you can see, the final value here, after dereferencing all these pointers, this is the address here, which we have 264FA, which is the actual value that holds the X value, which is 968. So let's define a method in our memory class, which automatically dereferences all of these pointers and goes down the pointer chain all the way to the final value. Let me show you how we will do this. It's quite simple. Let's define a public. We'll return an int pointer, and that's gonna be a pointer to the final address which actually holds the value that we need, for example the X location. And let's call it resolve pointer chain. And as parameters we're going to need the initial base address, so let's call it base address. That is going to be this one right here. That is gonna be our initial base address, and then we will need all of these offsets as parameters as well, so we can one by one dereference the pointers. So let's define an array and use the params C# keyword, which allows us to pass as much as we need of these values. So now let's first define a variable of type long for our current address. It's gonna be long because on a 64-bit processor the addresses are 8 bytes long. Now this is probably not the best way to write this. We might want to do some checks and use the int pointer type. However, read int64 here already returns the long, and I will just skip these checks. If you want to be more precise, you can do that if you want, but let's just do read int in 64 and pass in the base address. So what we do here is we are simply going to read the value at this address. Next, let's define a loop and let's loop through the offsets. And now let's update our current address to be the dereferenced value of our previous address, if that makes sense. Let me write it and I will explain it. Now, what we are doing here, we are simply going to these offsets. We are dereferencing the first one, the second one, and the next, until we reach the final one. We are just literally adding the numeric value of the offset to the current address that we have. For example, as you can see, it is the same way here. This one is 26483, ending at 80, and it is the one here, plus CO, which is this one, and that results in this one. Once we reach this one, we take it, move it up, and add 10, which is this one, and when we get the result we go up and so on. That is the same thing that this code is doing here. So once this is done, let's define a long for the final address, and it's gonna be the current address plus the last offset. So because there is no equal sign here, we will actually not go through this last address and read the value. Instead here, after we complete the loop and are at this stage right here, reach the second last address, what we do is we grab it and add the last offset to it. So we do this last step, but we don't dereference it yet, but rather keep the address of it, because we want to return a pointer to the final address and not the value inside the final address. So once we have this final address, we're ready to return it. Okay, and with that, our memory manipulation class is done. Now we are ready to write some fun logic. So let's go to program CS, remove this console write line, and let's find our process. Let's do var proc is equal to process dot get processes by name, and here let's do, actually if we go to, let's open a command prompt, and if we do task list, as you can see, it is called platformer space game. So let's copy this, put it in the quotes. And because this is returning an array of processes, because it is get processes by name, there might be more than one. We'll just assume there is only one and pick the first one. And we can actually do first or default. And let's just do if process is equal to null. Let's just console write line process not found, and let's return. Okay, now let's create a new object of our memory class. I'll actually create a field here. Let's do private static memory. Let's call it mem. And here let's do mem is equal to new memory. And let's pass in our processes ID. So process.id. And I actually defined this outside of the class. So let's move it in. Great. And now let's get the base address. As I told you earlier, we can easily access this address right here in these quotes, and we do it in a very simple way. Var base address is going to be proc.main_module.base address. That's it. And now it is time to resolve all these pointers and use these values that we found here. So let's define two fields for X and Y handles. And let's use our resolve pointer method that we defined. Let's do the X handle, so the pointer to our address that holds the X value is going to be mem.resolvePointerChain, and here is the cool part. Let's open cheat engine. Let's actually split view like this. Okay, so let's do base address plus, just like we see it here, this value. Of course, we will use hex notation, and then we want to input all the offsets. As you remember, we have a params int array which we can pass here, so let's do 0 or 0x0, then we have 0xco, 0x10, 0x50, 0x10 again, 0x60, and finally 0x25c. Okay, perfect. Now let's copy this, paste it here. Let's do for Y, and let's close this, open the Y pointer, and let's remove all of these, and let's do it again for Y. So we want this value here. It is actually the same. 0x0, 0x80, 0x68, 0x70, 0x30, 0x58, and 0x260. Okay, let me close this, minimize cheat engine, and let me open this in our full view here. So with that, we should have handles to our x and y values. Before writing anything else, let's just test this. Let's try something simple. Console write line x is equal to plus mem.readInt32, and let's pass the address. The good thing is we now have a handle to x, which we need to pass here, so let's just do x handle. And let's do another one, y is equal to the y handle. And as our game is still running, let's try to run this program, open the process, and try reading these two values. Okay, and there we go, we have an x of 968 and a y of 204, which if we open Cheat Engine are the same values. Awesome. Let's try writing as well to confirm it works. So let's do mem.writeInt32. Let's do the y handle and let's write 400. Let's see if we will get a jump here. Now let me open the game and let's hit run. Let's see if we're gonna get a jump. Oh, there we go. We are able to control this game from this external program here, the external cheat that we wrote. And from here on, we have done the memory manipulation. We have figured out the addresses, and the only thing left is to write the cheat logic, whatever you find cool. It is up to your imagination now to achieve any behavior you want using these values. For example, let's write a console type cheat. Let's have two commands for now. Obviously you can do whatever you want, but let's do if arguments 0 is equal POS. This is gonna be to get the position. And let's do another if for a command for TP. This is gonna be a teleport command. I will do only these two, and you can do anything else you want really. So for the position, let's write a quick method over here. Let's return a tuple of an x value and a y value. Call it get pos. And let's just do int x is equal to mem.readInt32, and we are going to read x, and int y is equal to this, and let's return xy, perfect. And here in pos, let's just do var xy is equal to get pos, and let's do console write line current position, and let's do x and y. Okay, and for TP, let's write another quick method, static void, call it set pos, and let's just do mem.writeInt32, and for x, let's actually have int x and int y for the position to set, and let's write at the x values address, let's write x, and at the y value address, let's write the y value. Okay, and here in TP, let's do a quick check and parse our arguments. Here we have a usage, and once we have the valid parameters, let's do set pos x and y. Okay, let's move this over, open our game, there it is, and let's run our external cheat, and let's try using it. I'm going to move over here, and let's do, actually, quick mistake, let's do only console write here, so it is not on a new line. Okay, let me zoom this in, and if we do pause, get our current position is 440, 108, so let's try to use this cheat to teleport up here. Let me do TP 440, and let's try 500 maybe, so we reach up here, but we need to use, not to use this, and boom, we just use our cheat to teleport. So now let's move forward. In fact, let me just try to TP maybe at 3000, so we don't have to walk. Okay, we ended up right here. Let me jump, move forward. Why not get the position here? Let's TP to 4200 maybe. And we are now on top of this box, which we couldn't get on previously. And finally, we can just TP to, actually let's just get position, and we can just TP to 4062, and let's do 200, and boom, we are inside the box. And from here you can expand on this however you like. As you saw, once the memory access is set up, you can build whatever logic you need on top of it. Hopefully this gave you a good understanding of how these kinds of external tools work and how the same approach can be applied in other projects as well. If the internal cheat video is already out, you should see it right here. Otherwise, YouTube will recommend the video it thinks you'll enjoy most. Till next time.